In this lesson, we're going to explore the importance of having a well-configured infrastructure to support test automation. At the heart of this is the concept of testability for the system under test, or SUT. Testability is about ensuring that the SUT is designed with the right interfaces that allow testers to control and observe its behavior. This isn't something that should be added later on. Instead, it should be incorporated during the design and implementation phases of the project. Typically, this involves close collaboration between a software architect and a test automation engineer. Together, they work to identify and implement the necessary features that will make the SUT more testable, which in turn makes automated testing more effective and efficient. To improve the testability of the SUT, there are several key solutions that we can implement. First, let's talk about accessibility identifiers. These are crucial when it comes to identifying UI elements during testing. Depending on the development framework you're using, these identifiers can either be generated automatically or set manually by the developers. Having these identifiers in place is essential for test automation tools to effectively interact with the UI elements. Next, we have system environment variables. These are specific parameters within your application that can be adjusted to make testing easier. For example, you might change a variable to enable debug mode or to simulate different user environments. This flexibility can significantly enhance the testing process by making it easier to reproduce and diagnose issues. Lastly, there are deployment variables. Similar to system environment variables, these are set before deployment begins. They help configure the testing environment to better support automated testing during and after the deployment process. By carefully setting these variables, you ensure that the environment is optimized for testing, leading to more accurate and reliable test results. When designing for testability, there are three critical aspects to consider. The first is observability. The SUT needs to have interfaces that allow testers to see inside the system, to understand what's happening under the hood. This is crucial because it enables test cases to accurately verify whether the actual results match the expected results. Without good observability, it's challenging to diagnose issues or confirm that the system is functioning as intended. The second aspect is controllability. The SUT must provide interfaces that allow testers to perform actions on it. These could be user interface elements, function calls, or communication protocols like TCP/IP or USB. Controllability is about ensuring that testers can simulate user interactions, change system states, or trigger events during testing. This ability to control the SUT is essential for comprehensive testing, especially in complex systems. Finally, there's architecture transparency. It's important that the system's architecture is well documented and easy to understand. Clear documentation helps testers to know exactly where to look for potential issues and how to interact with different components of the system. This transparency supports both observability and controllability and ultimately leads to better quality testing across all levels of the system. In conclusion, creating an infrastructure that supports effective test automation requires careful attention to the testability of the SUT. By focusing on accessibility identifiers, environment and deployment variables, and ensuring your system is designed for observability, controllability, and transparency, you lay the groundwork for a robust test automation framework. Remember, collaboration between software architects and test automation engineers is key to making sure that the SUT is well prepared for automated testing. By incorporating these elements early in the design process, you can significantly improve the efficiency and effectiveness of your testing efforts.